Hello, I think I'm going to call this one selective ambient occlusion or maybe art-directed ambient occlusion. Let me show you what I mean. Okay, here I have a test scene and you can see that I have this cylinder here, and if I move it, we get sort of an ambient occlusion effect on the floor and the wall on my stage background, but only on that object. So if I move it closer here, I'm not getting any ambient occlusion on any of the other objects, and I also made it red just to highlight it. And then over here, the cube, if I move the cube, that doesn't create any ambient occlusion on anything, but this icosphere creates ambient occlusion, and in this case it's purple or pink on the cube, and also this donut here, the torus, creates sort of an ambient occlusion effect on the cube and only on the cube. We don't have any other ambient occlusion in this scene. Now if I switch this over to cycles, it looks exactly the same, and that is actually a big deal with ambient occlusion, because EEVEE and cycles are completely different when it comes to ambient occlusion. And we're gonna have some fun with this after the intro. Alright, I cleaned up the scene a little bit, but I left in these objects so we can just reuse them and don't have to waste too much time. I have this background in here, so it's like a seamless backdrop, and then I have all these objects. I cleaned out all of the modifiers. What do I have? I have some lights in here, as you can see. So spotlights. This is basically all based on my startup file, Crispy's startup file, which you can get for free from my Patreon. Okay, so ambient occlusion. What is ambient occlusion? This is what Wikipedia says about ambient occlusion. It is a shading effect, and it gives you sort of like fake shadows. It's not real shadows. It's not based on lights and light sources and occlusions based on, light rays. It is a shading effect. It's like fake shadows or contact shadows. So how it works is basically it looks at the surface of an object, and it determines how far away are other surfaces of the same or other objects. And then if it's there's something close to it, it makes this surface darker. Okay, it's like a darkening effect based on the distance of the surface to other surfaces. That's all it is, and it's very fast. It can be done in real time. That's why game engines have been using this forever to fake shadows. And of course, if you also look over here in this image, it increases contrast, so it gives more more depth to objects. So what do we have in Blender for ambient occlusion? Here I am in EEVEE, and there is this global switch for ambient occlusion, and if you switch it on or off, you can see not much, but some things. Like, for example, look in this crease in here. If I switch on ambient occlusion, it darkens that little edge in there. So it increases the contrast a little bit by darkening these faces that are inside here, because they're close to other faces. Or if we look maybe over here, let's see, we have real shadows here from our lamps, but if I switch on ambient occlusion, down here you can see it becomes a bit darker, right? Because this torus, the donut, is close to that floor, and so the floor gets darker. Also the donut gets darker because it's a global option in EEVEE. Okay, you can open this here, and then you can determine the distance. So how far should these rays that are being calculated to determine if there is anything close by, how far should they shoot out? You can increase the factor and all of this stuff. But this is a global option, and if I switch it on or off, it affects the entire image. So this is not what we want. We want to art direct which object should cause ambient occlusion on which other object or objects, right? So that's that. In cycles, we also have a global switch for, where is it? For ambient occlusion. I don't know where it is. Let me quickly find it. right here. So in the world settings, we have this ambient occlusion switch. And I have never ever used this for anything because I don't quite understand it, to be honest. If you switch this on in cycles, basically all your lighting that you have in your scene becomes obsolete. It's completely ignored. All you have now is like this very bright global illumination. And yes, you do get ambient occlusion, so stuff gets darker where it's close to other stuff, but this is useless to me. And maybe I'm just not, I just don't know how to use it. Maybe I'm using it completely wrong. Maybe this is the greatest feature of all time. And if you use this for anything, please let me know in the comments down below. What do you use it for? How do you use it? How can we make use of this global ambient occlusion switch in cycles? Okay, this is also not what I want. But we have one other thing in cycles. We have shader nodes and we have the ambient occlusion node in shader nodes. So let's just go to this backdrop object here, and we should have some shading on here, right? Let me just get rid of this quick. Right, so this is what gives me this grid pattern here. We can basically ignore this. Really what we're looking at is one principled BSDF shader. And in cycles, like I said, we have a node which is called ambient occlusion. So I can go input or shift I hope. Hold on a second. Screencast keys. So shift A, input, and then there's ambient occlusion. It is a node. And if I look at what this node does, and this is only on my graph paper material, so on this, only on the background now, okay? And you can see, yes, on the background here, we do get ambient occlusion now. So the ambient occlusion output, that's all we're looking at now through a viewer node here, darkens the surface of this paper where there's other objects nearby. Now, also this ambient occlusion node has samples, so you can increase the quality. It has a couple of checkboxes, and it also has this distance feature, which is that same thing, like how far away do we have to check for other objects. Okay. Inside is the checkbox, which is basically a flip normals. So if you have a cube and you have this ambient occlusion nodes on it, it calculates, it shoots the ambient occlusion rays outwards, if you think about it like that, to find other objects. If you go inside, it's basically doing the same thing but on the inside, so it's like a flip normals switch. Only local means only calculate ambient occlusion if it's hitting the same object that this shader is on. So right now you can see we don't have any ambient occlusion effect here, because this would now only be affecting itself, like the paper background objects. So maybe we get some darkening back there, which we can't really see because it's so bright. But if you switch this off, only local, then all of the other objects are being taken into account for the ambient occlusion. So again, this is also not what we want for our art-directed ambient occlusion. But it's better than just the global ambient occlusion, because we can put it on into a shader, right? Now let's go back to EEVEE. And you can see in EEVEE, this node doesn't do anything. So it's not really working, but it is working if we switch on the global ambient occlusion. So now global ambient occlusion is on. We have this darker area in here. We have some dark areas in here. You can see we have ambient occlusion on the floor here. And I don't know where we can see this good. Maybe down here. If I change the ambient occlusion here, and if I change the distance, you can see it's actually affecting the ambient occlusion of the background, but still the global ambient occlusion switch is on, so we're still getting ambient occlusion in here. We're just affecting the paper now, so it is almost like the thing in cycles, but we have to have that global ambient occlusion switch on in EEVEE, which also gives us global ambient occlusion everywhere. So again, this is not what I showed you at the beginning, where the one object just affected one other object, or several objects affected several objects, right? If we want that, we need a little bit more control. And the way we can get this control is through the new geometry nodes. It's new in Blender 2.93, which is currently still in alpha at the time of this recording, so I'm in 2.93 alpha here. And if you want to follow along, just get the latest Blender version. Okay, so let me clean this up here. Let me switch this back to this. So we just have this graph paper back here. Okay, let's jump into geometry nodes and see how we can make our own ambient occlusion effect. We've already seen that it is based on the distance of one object to the other object where it darkens the area. So we can use geometry nodes to calculate that stuff ourselves and then use our result to influence a shader. I'm gonna start on my paper background here. So on my paper background selected, I'm creating a new geometry nodes, node 3, which gives me this input and output. If you're completely new to geometry nodes, I have a few videos here on the channel already, like first look at geometry nodes and then some updates and explaining the nodes, the attribute workflow, the point clouds and all of that. So check those videos out if you're interested. Now, what can we do here? So first of all, we're gonna work with attributes, right? So we need geometry, only vertices or point clouds can have attributes stored on each vertex. An attribute, it's basically like it's a storage, like it's a memory or like an additional custom property that you can put onto each vertex. That's what an attribute in the geometry nodes is. And really what we need is the attribute proximity node. Well, this sounds just like what we want, right? We want the proximity of the vertex to something. So let's plug that in here. It gives us the option to choose between points, which in case of using an existing geometry is just the vertices, the edges or the faces. Let me switch this to points just to show you something here. Now we can put the distance that this node calculates into a new attribute. Let's call it D for distance. So we have a new attribute now on each vertex. But we have to calculate the proximity of each vertex of our geometry to something. Like we need a target object. So we can shift A, we can get an input object info, and we can plug that geometry in here. And now we can select which object do we want our calculation, our proximity calculation based on. The node tree is on the paper and we're plugging in the cylinder. So now this proximity node tree calculates proximity between the cylinder and the paper. And it puts that proximity value into a new attribute called D. But we can't see anything yet because we're not doing anything with this D. How about we put it into, I'm still on the paper, we put it into a vertex color slot. I still have that in here, so I'm deleting that. And we're gonna create a new vertex color slot. And like we just already saw, I'm gonna call it AO for ambient occlusion. And now I can put my D into ambient occlusion. And I want that ambient occlusion value to be between 0 and 1, so I want it clamped down. Very easy way to do that is with an attribute color ramp. So we're gonna take our D attribute, that distance or proximity value, and we're putting it into our AO vertex color slot. So geometry nodes now takes care of like the type conversion because D is a value and AO is actually a vertex color slot. So this is all done for us automatically, and it is also now between 0 and 1 because that's what the color ramp here is. We still can't see anything. Why? Because we're not using our vertex color. So let's go back to the shader node. Where is it? Here we have the principled BSDF. Like I said, this is just that brick texture making that grid pattern. Now we can go input. We can input a vertex color. Where is it? So we're not using the ambient occlusion node. We're using a vertex color. Now we can pick our ambient occlusion vertex color that we have over here. And if we look at this now, we get nothing. Why is that? Well, we need geometry. We need vertices for a vertex color to have some detail, right? And if I go into edit mode here, you can see this entire background here doesn't have many vertices. It only has those on the edge here, but there's nothing in the middle. Those are just edges. So there's really nothing that we can see here because the calculation doesn't have any vertices to put our ambient occlusion onto. So first of all, we need to fix this. I'm just gonna go Control R and put a bunch of loop cuts in here on this edge, like maybe so. Okay, then down here I also want some more geometry, so I'm gonna do this again. I'm just looking to make sure that they're very close to squares. Back here they're not squares, but that doesn't matter now. Okay, so let's make some more geometry here. If it's not enough geometry, we can add some with a subdivision surface modifier, or even in geometry nodes with the subdivision nodes, right? So now this has geometry, and you can already see we get some like low resolution ambient occlusion going on here. Why? Because this guy here is close to the surface. So let's see if this works. Ambient occlusion. Let's go back to our geometry nodes. Where are they? Let's see if this changes anything. Yep. So here we're changing the black value. Here we're changing the white value, and you can see we have whatever the resolution of our geometry is. Like I said, maybe we want to increase our resolution. We can do this in here. We can go to mesh, subdivide, and subdivide like to 3 levels, and then we have much more detail here. Same thing as if we put on a subdivision surface modifier. Okay, now we have a lot of mesh on the paper. We can see that this guy, if I move him, is not updating. Hold on a second. Why isn't this updating? We're taking the original position of this object. We want the relative position. So now if I move him, we're getting ambient occlusion on the floor. Cool. Let me move him all the way back, and you can see an interesting effect here. So we're getting some effect up here, we're getting this effect down here, and we're getting something in the middle, but there's these white lines. Why is that? Well, again, this whole calculation is based on mesh data. So if I go into edit mode and I look at my cylinder here, you can see I only have vertices up here, then all of these in the middle, and then some down there. And that's why I'm getting this effect up here, in the middle, and down here. And there's an easy way to fix this, and that is we're calculating the proximity based on points, but we can switch this to faces, and then we get this. So now we're taking the faces of the paper, we're taking the faces of the cylinder, we're getting the proximity for that, and then we have this very nice looking ambient occlusion effect, right? So if I move them forward, I have it on the floor. And back here, we also get it on the wall back there. And if I go back in here, I can change, let me look through the camera here. I can bring up the black point here, make it really, it's also very interesting looking. Or I can bring down the white to get less of this effect. I can also switch this over to ease so that I have more of a, like a smoother gradient between the black and the white. Okay. So now we have this ambient occlusion effect on the paper, just on the paper, just from that cylinder. Let's go back to shading. How can we give this a color? Oh, basically What do we want? We want to use our principled. We want to plug this into the base color and somehow add it or multiply it on top of our base color. So we can go color, mix, we take this color, we take this color, we multiply that on top, right, like this. And then we have the graph paper back. We have a real shader, principled, and we get it darker where we have our ambient occlusion vertex colors calculated in geometry nodes. Of course, you could do this differently. You could use this as a factor to mix different shaders together even. So maybe you want it to be like the whole paper should be glossy, but where it's close to the cylinder, it should be more matte or something like this. You have all the options available that you have with the shaders now, because you can use your vertex color as a factor. Maybe you want it to be colored, not black, like now. Then you use this as a factor and you mix in red, and now it's backwards. So you might want to invert the factor. Is there a way? No, we just have to go color invert like this. And then we have red ambient occlusion, and it's just the cylinder on just the paper. Cool. So we created a node tree for this, right? It's, where am I? Geometry nodes, node tree. We're using this node tree here in a geometry nodes modifier on the paper. And I'm going to call this geometry nodes node tree AO for ambient occlusion, because we can reuse this now. That's the cool thing about these node trees. For example, let's do the thing that I showed at the very beginning. Let's take this cube here and make the icosphere and the torus affect some ambient occlusion effect on the cube only. So what do we need? The cube needs, it already has a bevel modifier. We're going to add a geometry nodes modifier, and we're going to use our ambient occlusion node tree on it. So now if I bring this closer to the cube, this should also affect the cube. But of course the cube material doesn't know anything about this yet. So let me see. The cube material is just blue. Again, we need to input our, where is it, vertex color, the AO1. Also, of course, it already has that. I don't know now if that created automatically, but you just need that AO vertex color because the geometry node writes into AO vertex color. So the cube has that here, and we're going to use that AO in here maybe. And then what do we get? We should get, yeah, it's already darkening. I don't know why it's so slow now. Not sure, but you know what? Let me go back to the geometry nodes. Maybe this is too much. Subdivide twice. And then let's go back into the cube shader. So it should mix. Maybe let's use this as a color mix. Let's mix between this original blue that we have here, between blue and where the AO is, it should be pink, and we use that AO as the factor, and then you have it here. Cool. So now if I bring the cylinder closer to the cube, we get this AO effect on the cube. But I don't want this guy affecting the cube. I want this icosphere affecting the cube. How can I do that? In my geometry nodes node tree here, I sort of have this like hard-coded in here, that the cylinder is what's affecting the calculation. I don't want that. And the coolest thing in geometry nodes is that we can actually pipe things out by using these empty sockets here to the modifier panel. So now in the modifier, we can change which object is affecting us, basically, or this object that the modifier is on. So now it says a cylinder in here. Okay, for the paper, this is correct. For the paper, we want cylinder, but for the cube, we don't want cylinder. We want icosphere. So let's put that in there. And now look at this. We have the icosphere. If I move it, it's affecting the effect on the cube. And this guy isn't doing anything anymore on the cube, but it is, of course, on the paper. So how can I get another object added onto this? What if I also want this torus down here, the donut, affecting the cube? Well, it's very easy in geometry nodes. So all we have to do is we need a second object input, clear out this cylinder value, and then we just go geometry join. We join the first object and the second object, and now we have two objects affecting the proximity calculation. And just for fun, we're gonna add a third one. Cool. And then we pipe those objects out to our modifier panel like this. So now they become variables. They're not fixed and hard-coded in the node tree anymore. They are now variable. So on the paper, let's go back to the paper. We just have the cylinder. We could add, let's add the torus. So now the torus also makes the paper red, right? But that's not what I wanted originally. I want on the cube, I want the torus to also affect the cube. And then we even have a third one here. I'm just gonna leave it empty. This was just to show you that you can do this like that. And you have a reusable ambient occlusion node that, depending on the object that you put it on, or that the modifier that you have on the object, you can even set different properties here. So now if I move the torus, I'm getting effect on the cube and nowhere else. So now really I can direct, using this reusable geometry nodes node tree, I can direct which object should have which ambient occlusion, what color should it have. Maybe it should just darken like shadow or fake shadow, or even what we're doing here to set different colors. Or you can mix different shaders completely, like I said before. And you can always define you want this geometry nodes modifier, use the AO node tree that we have on this object, and then in the shader of this object you determine what do you want this AO vertex color group to do or to influence, right? So this is it. And let me look through the camera again. Like I said before, whoops, this is now EEVEE. So we're actually doing something here that you can't really do in EEVEE with the, like I said before, you have to enable the global ambient occlusion, but maybe you don't want that. So now you have local, very selective ambient occlusion in EEVEE. And if I switch over to cycles, you will see it looks exactly the same and it works exactly the same. I move the cylinder, it recalculates the red on the paper. If I move the icosphere, then now we're too far away. We don't get any effect, and if I come closer, we get the effect. How do you change your calculations for that distance? Of course, you do that in geometry nodes here with that D value or attribute that we now have on the geometry. Okay, so you can plug in some math nodes in here. You could stretch it out, or you can use this color ramp to change the effect, whatever you can think of. This is really cool. And now for a little bonus effect, I'm gonna switch back to EEVEE because it renders faster for the recording here. Something that I haven't talked about before in any of the other videos, but that is very, very awesome, is the fact that we have this AO node tree now in this modifier here on this object. Okay, or let me go to the paper. So here we have the AO on the paper. It's being affected by only the cylinder. And we're putting this D attribute onto our geometry. And that is actually on, this is not just local to this node tree. This is on the geometry now. So if we put another geometry nodes modifier underneath our first one, in this node tree here, in this new one, we also can access that D attribute that we set in this one, because it comes after. Let's, for example, use the D, the distance, proximity, to offset the geometry of the paper. So maybe we want to shift the geometry away from the cylinder in this case. Okay, how do we do this? Well, let's do an attribute vector math. Plug it in at the back here. And we want to somehow take our position. You can see that in here we have the attributes that the other geometry nodes, a modifier, put onto the geometry available. D is the distance, the proximity calculation. AO is also here. And this is really awesome because we can use this D now. So what do we want? We want to take the position of the vertex, and we want to add the normal to it and put that back into the position. So then we get this. So we're already shifting our geometry along the normal. So the floor comes up and the back comes forward. Yeah. But we don't want to use normal, we want to use D. Okay, so it looks like this. You can see now we're actually already getting an effect here, but that's also not what we want. We need to do some more vector math because we want to take the normal, multiply that by the D, and put that into something new like an N, and then over here we use N. Cool. But this is a bit extreme. You can see it's already working. So the cylinder, or our ambient occlusion, which is where the cylinder is, we get like no change in the geometry, and everything else that's further away is changing a lot. So let's do some attribute. Let's take the new map range node. This is brand new, by the way. And we take our D, and we call it like normal D or something. Give it a new attribute. Over here we use normal D. And then we can turn down the effect here with this max value. So what do we get here? Cool. So now we're warping our background. We're warping the space-time continuum. Hey, if you're into physics simulations, and you have a grid like this, and you want to visualize how gravity warps space-time or something, this is like the perfect effect, isn't it? So let me see how I can make this look cool. So this is still too far away. Maybe we want to clamp this somehow. Maybe we don't want to use the D. Let's go back to the other node tree. So here we have D, and this is going into AO, which is a vertex. You know what? After we go into AO, we just clamp our D and clamp it to D so that D itself is clamped. And then what does that look like? Let's go back to this guy. We have this. Yep, this will be that space warping that I was talking about. And you can see the cylinder is now pushing away the paper. And we can change the effect here and make it subtle. Of course, now it's pushing the paper up here and our torus is now hidden, but you get the idea. We could even flip this, so we could do something like this. Now the paper is pushed away here and it's closer to the cylinder here. And you can see we're using this D value not only to make the paper red here, but also to shift geometry around. I think this is really awesome. Okay, maybe this was very complicated now, but the fact is, one geometry node's modifier adds attributes to the geometry, and another geometry node's modifier can use that. So we could call this now warp, and it's based on and it needs AO, okay, in this case. But you can see, you can create your own like modifiers or node trees that do stuff and put attributes on, and then use those in other modifiers later on, which I think is really, really cool. All right, now, not quite sure what you could use this for, but I think it is very cool that we can art direct where we want ambient occlusion, and it looks the same in EEVEE and in cycles. I have used this effect before in product visualizations, where I want a little bit of extra like contact shadow on the ground where the product is sitting. I don't want any ambient occlusion anywhere else. I want photorealistic lightings and renderings. I don't want this shading effect, but sometimes it adds, it can add contrast, which is sometimes important. If you have like a white background rendering for an online shop and your product is white, you need some sort of extra shadow. Just the shadow of the lights sometimes isn't enough, especially because you always want a lot of lights for product visualization. And then it starts to look like it's just floating in air. And that extra fake ambient occlusion, fake shadow, contact shadow, that can really be something. And I just love it that we can do this now. Let me know what you would use this for. It doesn't have to be ambient occlusion. You can use this for other things too. In the comments down below, I'm looking forward to your input and ideas. That's it. You know the drill. Thanks for watching. Chris P. out.